This is Module 1, Unit 4, Part 3 of File Management in Digital Electronics. We will be covering in this section the lesson topics of integrated circuits and overview, processors and overview, computer memory RAM, and other types of computer memory. The learning outcome, our first learning outcome in part 3 is to define integrated circuits and explain the role they play inside a computer. Computers and digital devices are electronic devices that use electronic signals to process data. The electronic parts of a personal computer store, process, and transfer the data. In the beginning, the electronic parts are large and bulky. Over time, the electronic parts have become smaller and more efficient. The most significant technology that made the miniaturization of electronic parts possible is the integrated circuit. What is an integrated circuit? An integrated circuit, IC, is a very thin slice of semiconducting material, such as silicon, and which is packed with microscopic circuit elements. These elements include wires, transistors, large gates, and resistors, and are used to create miniature electronic parts and pathways. Electronic signals and bits and bytes travel over these electronic pathways. The terms computer chip, microchip, and chip are all synonymous with the term integrated circuit. Chips are manufactured in sterile environments to protect their parts. What protects chips from possibly being damaged? Each chip is packaged in a protective carrier or chip package. Chip packages vary in shape and size, including the dual inline package chip package, and the LGA, the land grid array chip package, and the DIMM, dual inline memory module chip package, as seen on this slide. How are all these chip packages connected to the computer? Chip packages are connected to the computer's motherboard. The motherboard is the computer's main circuit board. The DIP and the PGA, the DIP is the dual inline package, and the PGA is the land grid array packages are plugged into the sockets and connectors on the motherboard. The DIMM chip packages and small circuit boards are plugged into the slots on the motherboard. Some chips are soldered permanently in place. The motherboard contains electronic circuitry that connects all these parts. Expansion cards attached to the motherboard through expansion slots. How are these packages connected? on the motherboard. What is a processor? A processor is also called a microprocessor in one type of chip or integrated circuit. A main processor in a personal computer is the CPU, Central Processing Unit. It is designed to process instructions. A processor is a very complex integrated circuit containing hundreds of millions of miniaturized electronic parts. It is the most important and usually the most expensive single part of the computer. Looking inside a computer, you can usually identify the processor because it is the largest chip on the motherboard. Most of today's processors are housed in a PGA chip package. Digital devices have processors, as you might suspect. Processors for mobile devices such as smartphones, cameras, and tablet computers are smaller than processors in a desktop computer. So our next outcome, we will explain how CPU factors affect computer performance. The Central Processing Unit, CPU, contains all the circuitry that performs the central processing tasks of the computer on a single chip. Different personal computers come with different processors. Processors have certain factors in common. Knowing how each of the processor factors affect the performance of a computer can help you make an informed decision when buying a computer. What factors affect performance, processor performance? The processor's performance is affected by several factors, including number of cores, clock speed, bus speed, word size, and cache memory size. These factors combine to affect the processing speed, which determines the computer's performance. A processor's factors are described as part of a processor's specifications. A processor's specifications or specs are available on the manufacturer's website. What do processor specs tell me about the processor? The processor that contains circuitry for more than one processing unit on a single chip is called a multi-core processor. Multi-core processors are faster than processors with single core. To gain maximum speed, however, your computer's operating system and software should be optimized for multi-core processing. Most operating systems support multi-core processing. The 2.4 GHz i5 processor has 2 cores, giving it the equivalent of 4.8 GHz performance. What is clock speed? The processor clock is a timing device that sets the pace, a clock speed for executing instructions. The clock speed is specified in megahertz or MHZs, which are millions of cycles per second, or gigahertz with GHZ, which are billions of cycles per second. A cycle is the smallest unit of time a processor can recognize. The faster the clock, the more instructions the processor can execute per second. For the processor in the sample ad shown in a sample ad, the clock speed is 2.5 gigahertz. This means the processor clock operates at 2.5 billion cycles per second. What is bus speed? A bus is an electronic pathway that carries the electronic signals between the electronic parts of a computer. Bus speed identifies how fast the electronic signals move along the bus pathway. FSB stands for front side bus. The data bus refers to the main circuits that carry data at lightning speed as pulses of electrical voltages. The part of the data bus that runs between the processor and RAM is called the local bus or internal bus. This is the fastest part of the data bus because it has to keep up with the data demands of the processor. What is word size? Word size refers to the number of bits that a processor can manipulate at one time. A processor with a 32-bit word size, for example, has 32-bit registers, processes 32 bits at one time, and is referred to as a 32-bit processor. Processors with a large word size can process more data during each processor cycle. Today's personal computers typically contain 32-bit or 64-bit processors. What is cache? Cache, also known or called RAM cache or cache memory, is high-speed memory that a processor can access more rapidly than memory elsewhere on the motherboard. The amount of cache memory as well as its location affects performance. A level 1 or L1 cache is built into the processor chip, whereas a level 2 or L2 cache is located on a separate chip, so it takes a processor more time to get data from the L2 cache to the processor. Usually cache capacity is expressed in megabytes. The processor in this sample has 8 megabytes L2 cache. So what happens inside a computer chip? A processor contains circuitry and components divided into different kinds of operational units, such as the ALU and the control unit. The ALU, the arithmetic logic unit, is the part of the processor that performs arithmetic operations such as addition and subtraction. It also performs logical operations such as comparing two numbers to see if they are the same. The ALU uses registers to hold data that is being processed. The processor's control unit fetches each instruction. Data is loaded into the ALU's register. Finally, the control unit gives the ALU the signal to begin processing. On the screen, we illustrate a processor control unit and its ALU preparing to add 5 plus 4. So the control unit fetches the add instruction. They take the 5 and the 4, and the control unit loads the data into the ALU for additional operation. So let's go to continue on with learning outcome 8 and define the RAM and explain the importance of computers. Memory is electronic circuitry that holds data and instructions so it is available when needed by a computer. Computers use 3 categories of memory: random access memory, called RAM, virtual memory, and read-only memory, called ROM. Each type of memory is characterized by the type of data it contains and the technology it uses to hold the data. Let's discuss the random access memory, commonly known as RAM. What is RAM? In a personal computer, RAM, random access memory, is the waiting room for the computer's processor. RAM is usually several chips or small circuit boards that plug into the motherboard. RAM holds operating system instructions that control the basic functions of a computer system. These instructions are loaded into RAM every time you start your computer. These instructions are stored in RAM until you turn off your computer. RAM is also a temporary holding area for program instructions as well as for data waiting to be processed, displayed, or printed. In addition, RAM holds the results of processing until they can be stored more permanently using the storage system. As you see on the screen, this is RAM as it is a temporary holding area. Does RAM matter? Yes. The amount of RAM your computer has makes a difference on how well your computer can perform. Usually, the more RAM your computer has, the better the performance. In fact, along with the processor speed, RAM capacity is the other most important factor in determining and comparing the power of a computer system. The performance of your computer is directly related to how much RAM is available for your applications, data, and operating system. RAM is made by different manufacturers. Be sure to read reviews about RAM product before purchasing it because quality can affect performance. How does RAM work? In RAM, electronic parts called capacitors hold the bits that represent data. You can visualize the capacitors as microscopic lights that can be turned on or off. A charged capacitor can be turned on and represents a 1 bit. A discharged capacitor is turned off and represents a 0 bit. You can visualize the capacitors as being arranged in banks of 8. Refer to the slide as we discuss this further. Each bank holds 8 bits or 1 byte of data. Each RAM location has an address and holds 1 byte of data. A RAM address at each location helps the computer locate data as needed for processing. The content of RAM is changed by changing the charge of each capacitor. The capacitor charge is changed when you input data and the computer processes the data. So looking at the example of how RAM works, the 2 charged capacitors that had at this RAM address represent the letter A. The different sequence of charged capacitors represents the letter B. Another sequence, charged capacitors, represents the letter C. How does RAM differ from hard drive storage to my computer? RAM holds data temporarily in circuitry that's directly connected to the motherboard. In contrast, the hard drive stores data on magnetic or solid-state media. Data in RAM is temporary storage. Data storage on your hard drive storage is more permanent. In some respects, RAM is similar to a whiteboard. You can use a whiteboard to write formulas, erase them, and then write an outline for a report. In a similar way, RAM can hold the numbers and formulas when you use the spreadsheet software to manage a budget, and RAM can hold the text of your essay when you use word processing software. Unlike the whiteboard, however, RAM is volatile, which means that it requires electrical power to hold data. If the computer is turned off or if the power goes out, all the data in RAM instantly and permanently disappears. How much RAM should a personal computer have? The amount of RAM your computer needs depends on the software you use. The capacity of RAM is expressed in gigabytes. Today's personal computer typically feature 2 to 8 gigabytes of RAM. Handheld devices usually have 1 to 2 gigabytes of RAM. If you are using a Windows computer, you can view information about your computer, including how much RAM is currently installed, using the control panel as shown on this slide. RAM requirements are routinely specified on the outside of a software package. If you want to buy a new program that needs more RAM than installed on your computer, you can purchase and install additional RAM. However, the amount of RAM is limited by the computer's motherboard, such as by the number of slots the motherboard has to hold RAM. The manufacturer of the motherboard sets the limits. Also, if you can plan to upgrade, contact the manufacturer of the computer or motherboard so you can be sure to buy the correct type of RAM. So our next outcome deals with other types of computer memory. And we'll explain how a computer uses virtual memory and ROM. In addition to RAM, the computer uses virtual memory and read-only memory, which is called ROM. These are main categories of memory are commonly used in computers. Let's talk about these types of common memory and how all computer memory types work together. What is virtual memory? When RAM nears capacity, if you open several application programs and several large graphics or videos at the same time, you can push RAM to its limit. When this occurs, the computer slows down. You might notice that it takes longer to load a screen or respond to a command. To help solve this problem, the operating system uses an area of the hard drive to temporarily store data from RAM. And this area of the hard drive is called virtual memory. The data that has been moved from RAM to virtual memory is called swap file. It's called a swap file. Virtual memory stores parts of a program or data file until needed. By exchanging the data in RAM with the data in virtual memory, your computer gains almost unlimited memory capacity. Too much dependence on virtual data can have a negative effect on your computer's performance. Getting data from a mechanical device such as a hard drive is much slower than getting data from an electronic device such as RAM. Installing as much RAM as your computer system allows will help your computer improve its performance. What is ROM? ROM, read-only memory, is a type of memory that holds the computer's startup routine and other basic system information. ROM is housed in a single integrated circuit and is usually a large chip that is plugged into the motherboard. Unlike RAM, which is a temporary and volatile, ROM is permanent and non-volatile. The instructions in ROM are permanent and are not lost even when the computer power is turned off. The only way to change the instructions in ROM is to replace the ROM chip. And to overcome this limitation, some newer computers use flash memory chips instead of ROM for storing the startup routine and other system information. Flash memory chips can be changed, and they do not lose data when the power is turned off. So if you have any questions, this is the end of part 3. Once again, go back into the Canvas pages, find I have a question, click on it and write your question, or either go to the inbox and send me a question from inbox. This is the end of Module 3. This is the end of Module 1, Unit 4, Part 3 of File Management and Digital Electronics.